Assalamualaikum and selamat sejahtera. In this video, we will discuss three-phase uncontrolled rectifiers with resistive loads. Before we focus on the rectifiers, let's do some revision related to the three-phase power system. The circuit in the circle shows a Y-connected voltage sources. Based on the configuration, we can see these voltage sources are connected at the same neutral point. Because of that, they are supplying phase voltage in the system, where VR supplies voltage for the red phase, VY for the yellow phase, and VB for the blue phase. And you can write the equation for these voltages as follows. According to the voltage equations, we can say all phase voltages have same wave shape, which is sinusoidal, with the same amplitude value, and they are running at the same frequency. However, based on the angle values, we can see that all phase voltages are separated from each other by 120 degrees. Next, let's look on these voltages. According to the circuit diagram, these voltages are measured from phase to phase or line to line. Therefore, these voltages are called line voltages. And if you complete the connection between each line voltage, you can see the line voltages are connected in delta configuration. Later, in order to obtain the equation of these voltages, you need to apply KVL inside the loops. Based on the equation of the line voltages, we can see that the peak amplitude of the line voltages is higher than the peak amplitude of the phase voltages. Other than that, based on the phase angle values, we can say that the line voltages are leading the phase voltages by 30 degrees. In the three-phase system, it is crucial to know how to sketch the voltage waveforms correctly. Usually, I will sketch 6 columns of 60 degrees in width. Next, I will use the voltage equations to sketch the waveforms. From the equations, you can know the wave shape of the waveforms, the peak amplitude value, and the frequency value, and also the starting time of each waveform. Now, let's sketch the waveforms together. We will start with the red voltage. Since the phase angle of the red voltage is equal to 0, therefore, the starting time of this voltage is also at 0 point. Next, we will sketch the yellow voltage. Based on this equation, we can see that the yellow voltage is lagging the red voltage by 120 degrees. Therefore, the starting point of this voltage should be at omega t equal to 120 degrees. Lastly, we will sketch the blue voltage, and according to the equation, the starting time for this waveform should be at omega t equal to 240 degrees. Now, we have a complete voltage waveforms for the three-phase system. This figure shows the circuit topology of a three-phase uncontrolled half-wave rectifier with resistive load. As similar to the single-phase half-wave rectifier, the three-phase half-wave rectifier is capable to rectify only the positive half cycles of the three-phase voltage waveforms. Based on the number of the positive half cycles, therefore we need 3 diodes to conduct the line currents. Based on this circuit diagram, we use diode D1 to conduct the red line current, diode D2 to conduct the yellow line current, and diode D3 to conduct the blue line current. Other than that, we can see all these diodes are connected to a Y-connected voltage sources.